Okay, so let's start with another algorithm known as SVM, that is support vector machine, and the data set that we are going to use is iris. So iris is a very versatile data set, and it is used in various learnings and also for various kinds of exercises. So we are first, as usual, let us clear all the outputs. So we will clear it and then we will start our working. So it is all cleared now. So with this we are going to import our pandas. So we run this. We are also going to load the data iris, that is like with this code, iris is equal to load this, and then we are going to check for the keys, that is what are the various features available in this data, target names, description, feature names, etc, etc. Then we are going to actually get the feature name, that is sepal length, sepal width, petal length, petal width. And then we are also going to check the description of this, that is description, data, feature name, file name, target. Again the same thing, not much of a difference, but then it is all required so that we can have better understanding. This is also done. It has gone, the data set has gone to a DF data frame, and all these features have also are available to DF. Now we can see the top 5 rows of the data frame, that is with this. Then we are going to have the target into DF target, and then again we are going to check for this. So we can run this, and you can see that the target 0 is the the code which is given for the different kinds of say variety of flowers that we have, that is setosa, versicolor, etc. So we have this. Then we are getting like this, that is the 3 types of flowers, that is setosa, versicolor, virginica, right? So all they are available now, and that is all into this particular data frame, that is iris. Now we are going to check for the 0, that is for setosa. We are going to check that details. So we will see that the top 5 rows are available for the target 0, and 0 means that setosa, right? So this is all for the setosa. Now we are going to check for the next flower, that is versicolor, and this is for that, right? Then for the third virginica also we are getting this. So all these are available to us, and we are clear that this is the type of data that is available for different kind of flowers. So we can see that record 0 to 49 are setosa, 50 to 99 are versicolor, and 100 to 149 are virginica. And the same can be checked also, that we have seen, right? Now we are going to get the names of the flowers, and that to get the name of the flower we are using this code, that is df flower name, df dot target, apply lambda x. So we are getting the x, the target name into this, and on running it we are getting the details here. So we can see that once you run this, that is df dot head, you will see that the name of the flower is available now. Target, this is the code for that, and this is the name of the flower, right? The next is that we are going to import the matplotlib for our various graphing and plotting, etc. So that can be imported now. Now we are going to have that different flowers into different kind of data frames. The df target 0 is into df0, target 0 is equal to 1, df1, and 2 into df2. So this is again we can run, and so that the data goes there, and then we can check the data here, that is like this, right, for df0, and this is for df1, and the next is for df2. This we have also seen earlier, but now it is more clearer. So that is very important, that we must be as familiar with our data as it is required. Now we are going to create the scatter plot for this, and for that we write this code, that is plt scatter plot, sepal length, sepal width for df0, and that is sepal width, and color is green, and the marker is going to be plus, that is with plus dot sign the df dots will be available to us. Similarly for the another points, that is for sepal length, sepal width, color is going to be blue, and marker is going to be dot. So we can run it, and we will have a scatter plot there with plus sign and the dots. So you can see that scatter plot has been created, and it clearly shows that the green color and the blue color. The next we can get for the another set of data that is for df0 and df1. So if you want to check between the two, we can get that also. Code is almost same. df0 sepal width, sepal length, sepal width, color is green, marker is plus, and again for df1 we are getting it. So that also is available to us, and we can run it. Code is almost same, so you can see that we have got almost same kind of a scatter plot here also. Then another scatter plot that can be created, and here we are getting the df0, df1. Now we are getting petal length and petal width, and color is going to be green, and again for this we are getting the petal length, petal width, and color is going to be blue. So again we can run this and we can get another plot like this. So you can see that different scatter plots are available to us for different purposes and for different points that we want to check, or variables that we want to check. Now we are going to have a seaborne. So we are importing seaborne for that, and we are creating a heat map for every data frame that we have. So here we are using df0, and we want to see the correlation between two different variables. So we can run it, and we can see that for df0 this heat map has been created, and the heading is correlation in this of iris classes, right? And the four variables, that is sepal length, sepal width, petal length, petal width, is available on both y-axis and x-axis, and this is the color plot, a bar. So this shows the intensity of the color, right? Similarly, we are going to have for the df1, again the heading and code, everything is same, so we can run this also. That also gives you another heat map for df1. Then we are going to have another heat map for df2, that also can be created with the help of this code. Say code is same, so I am not repeating it again. So but you can see that the same code we are writing for different data frames, right? That's how we can get it. Now since we want to test it, we have to import the train test split, and this is available in the sklearn under model selection. So we can import this. It has done. Now we need to drop the column. Now we have created the flower name, now we don't need it, so that is why we need to drop. And for dropping, we have got the x df drop target flower name, that is, this is what we want to drop, and axis is column. So we can drop from here, and when we go for this, you can see that we have got the details of that. So now flower name is not available, right? Similarly, we are going to have the for y. So again you are going to get these details, right? Now we are going to do our exercise, that is xtrain, that is support vector machine that we are going to create, and we are using that. So xtrain, xtest, ytrain, ytest, and train test split. And now we are going to use x and y, the data where we have transferred those details. Test size is going to be 0.2, that is 20% is for testing and 80% is for the training. So this again we can transfer here, so that all this data has been trained and it has been split also as per our specifications. Now let us see the length, what is the number of rows and columns, so that we can see, because now for x train we have 120. Remember that we total had 150 rows, and 80% have been kept for the training. So out of that 80% means that 120 rows are kept for the training purpose. That is what the meaning of the len x train. Similarly for test, the remaining is for the testing. So you can see that 30 is left for the testing part, right? So from sklearn, now we are going to apply the SVM, that is support vector machine. This is the algorithm which we are using, and for that we have to import the SVC also. So model is SVC, so that is why we have mentioned this. Now we are going to fit the model, right? So now we are going to, because we are using this model and we have to fit into our data that we have split for training and testing, etc. So we are doing that, and then you see it has been fit here. That means SVC is equal to C1, break type, false. These are the additional things. So if you want, you can go into details, but normally it is not required, because so long as it serves our purpose, that is what is required. Now we are going to check the score of x test and y test. So we can, by writing this code, we can get that. You can see that the model score is 96.966666. So that means almost 96-97% is the score. This is score, right? Now we are going to check for the classification of this. So classifier SVC kernel, the logic that we are going to use is linear, random state is 0, and classifier is X-train Y-test, and we are going to fit it into this so that we can classify whether the flower is setosa, versicolor, virginia, or whatever it is. So we are going to predict, and Y predict is classifier predict X-test, right? So this test where we had segregated our data for the testing purpose, from there we are going to predict it. So that data is going to be used here, and we are going to get it on in this Y-pred. Now from sklearn matrix, now we have to check what is there in the SVM. So that is why we need the matrix also. So import confusion matrix, and this confusion matrix after importing, then we are using as CM confusion matrix Y-test Y-pred, and print CM. Now we are going to print CM, that is confusion matrix, right? And then from sklearn model selection, import cross validation score. Now we have also to check the accuracy part. So accuracy is equal to cross validation score estimator classifier X-train and Y-train, and CV cross validation is equal to 10. Now we have to print it, that is accuracy as per the format, that is 2 decimal points, and the format accuracies mean that it is multiplied by 100 so that we get the percentage, and similarly standard deviation also in the same fashion, and we are getting the format as accuracy standard deviation, and again multiplied by 100 means that we are getting 100 in percentage, right? So we run it, and you get the confusion matrix first. For this command that we have written, that code that we have written as print CM, so we got this confusion matrix, and for this the accuracy is 97.5%, right? And standard deviation is 3.82. This has come with this kind of a that code that we have written here, that is print accuracy, this percentage, and accuracies are come, and now the standard deviation. So both these have been printed here and are available for our understanding. So both accuracy and standard deviations are there, and these are in percentages as per our code mentioned here, right? So this is how we can create, and this, since we got accuracy of 97.5%, which is fairly good, right? So anything that you get more than 90% is considered as a very good score, and we can say that the model is working very effectively. That is what because we have a 97% of accuracy, which is very good model, and with the confusion matrix we can say that we have just only one misclassified data, right? So that means just 2.5% is not giving the correct result. That's it, right? So that is how this particular model can be used, and that is why support vector machine is something which is very, very commonly used and very effective and very accurate also, right? So this completes this tutorial. Thank you.